factors are really the factors where you pay for your functions in the cloud. So just here, GraalVM enters the scene, and I have talked in my first talk a bit about this. I will be diving deeper. So we were not talking a lot about the GraalVM in general, but only about the images, native images. Generally, probably everybody knows what is GraalVM. It comes in two flavors: Enterprise Edition, where you will get a better performance, but you have to pay for this, and you will receive this for free, this Enterprise Edition in the Oracle Cloud. Generally speaking, this is the interface, and the thing which is really important for me is this substrate VM, which allows you to build native images, and we will see what the advantages do they have. So the native image, to build native image, you are required to use ahead of time compilation, and that means that all reachable methods, fields, and classes, only they will be packed. So they will be figured out just what is really needed for the application, and then the native image will be created, depending on your platform, ALF for Linux, Mac, or for Mac world, and just also there is a native image for Windows. So this is the situation. If you don't use your native image, then Java will be dynamically executed. And if you use substrate VM, which generates the native image, then Java is native precompiled. And that's the difference. And of course, if you have the native executable, then it will significantly reduce your cold start times and even memory footprint. So you will have nearly always something below 1/2 of the second of the cold start time, even because when creating the native image, they pre-initialize every static block of your code. So all your static initializer will be also pre-warned. And also they don't consume too much memory, because everything which is not needed won't be included in your native image. And this is some kind of situation we are currently in. This native image can help adopt Java with serverless, because it tackles this cold start and also the cost aspect. But the challenge is that GraalVM is its own executing environment. And if you go to your cloud provider, you will see you can select only Java 8 and Java 11. This is OpenJDK, Coreton, something like that, but it's not GraalVM. But I think really all cloud providers gives you the opportunity to provide your own custom runtime. And this is the opportunity to provide your this with AWS world, this is so-called Lambda layers and Lambda runtime API. And what this concrete means, that you can provide your Linux executable. It should be Linux executable, which is the native image. So the specification for AWS is you should provide the file called Bootstrap, and it should be this native image, which is really the GraalVM native image. So there is the possibility to do this. Of course, you have to manage this custom runtime. So this is nothing that will be managed for you, like Java runtime and so on. So this is a bit overhead, and you will pay a bit of penalty for using your runtime via custom runtime. So if you select Java 8 as managed runtime and you run your application, then you build your custom runtime using Java 8. You will pay a bit penalty, because there is API between to call this runtime through custom runtime. But generally, GraalVM gives you a choice: just-in-time compiler or AOT compiler. So you are not forced to use or think what is the situation. Is it serverless? Is this microservice? And decide what's the best situation for you. And everything has trade-offs. So ahead of time compiler is good for startup speed, low memory footprint, and small packaging. This is something very important for the serverless world. And with just-in-time compiler, it's optimized for peak throughput and reduce max latency. Of course, the situation is that to build the native image, currently it costs 3.5 minutes for the simple function. So you have to wait, and with just-in-time compiler, you can test this quickly. So this is another thing which is small change, and you really have to wait in order this image to be built, or you can test this with just-in-time compiler, your functionality. But generally, there are also other trade-offs. So the situation is also in Java world, we are accustomed to use the frameworks like Spring, Spring Boot and so on, because it gives us productivity. And we would like to use them also for serverless application to just to be more productive. And the Spring and Spring Framework, they rely heavily on reflection. So I didn't see people who used Spring with Java for serverless only for a limited use case where some kind of application runs only one time per month and the cost is not the issue, then it's okay. And just this brought many developers to rethink how to build the application in the cloud. So 2 new frameworks, Micronaut and Quarkus, entered the scene, even to solve these issues for the Java developers. And of course, they make different trade-offs or assumptions from the beginning. So they rely as little as possible on reflection. And this also will speed up your application even if you use this framework and don't use GraalVM. So just even without GraalVM, these applications, these frameworks allow you to be quicker. And we will go with very basic and simple examples through these applications because there is no much time left, but in order for you to see how to build this application, so some small examples. Micronaut Framework, very easy to define function, Lambda function, just you can use function interface, and just it's the plain Java code. The only one thing where you rely on Micronaut is here, just this declaration of the function bean, which then imports the Micronaut package. And what I really like about Micronaut, just you can even write your Spring application, but then you can process Spring annotation with Micronaut. So in the end, you have your Micronaut application with as less reflection or no reflection in general. But of course, you can also use Micronaut annotation, then also that's totally fine. It gives you also validators, which we are really accustomed to, and you also have the API gateway integration to link the public API with Lambda and so on. It's just a very useful tool. What's currently is the problem that you only have Gradle plugin. This is since several weeks, and no Maven plugin to build your native image with Maven. So you have to manually do this in case you use Maven, just to use this native command and then zip this with your native image. What's really interesting is that the founder of Micronaut is Graham Rocher, who is also known for Groovy and Grails and so on. And he joined Oracle several months ago. So we will probably see some kind of cooperation from Oracle with Micronaut, but I'm not quite sure. But it means that just probably Micronaut will be supported some kind via community. Quarkus, also this is the same thing. This is the framework for microservices and serverless application, but supported from Red Hat and IBM. And just the same situation here. I used AWS API. There is even no dependency to Quarkus in your code. You see the inject annotation from JavaX package. So simple way to write your function. But what I really like in Quarkus is that you have Maven plugin with profile native, and you have native image goal to build your native image directly with Maven -p for profile native package. So just a lot of steps taken away. Here, there are additional features. Also, you can create your app from the website, like Spring.io initializer, also API gateway integration and Funky. Only to mention briefly what Funky is, just provide some kind of generic way to deploy your functions to different cloud providers, also to Azure and Knative. So for multi-cloud world, I don't want to discuss if multi-cloud has its use case. Of course, yes, but depending on your use case, if you are locked into your cloud provider, you will probably lose features if you use Funky. So just decide for yourself if it's the way to go. It's currently better. And Spring Framework, they have a very difficult job to do, because the framework itself relies heavily on reflection, and they entered the scene only the last year. And Micronaut and Quarkus, they are for 2 years currently, so they are way ahead. But also Spring has this GraalVM native project where they experiment with integrating GraalVM, and the code looks pretty similar to Micronaut or Quarkus. Only the dependency to Spring is this auto-wired application. Otherwise, we use function interface. You can use Amazon SDK, which is currently a bit boring, that you are required to use demo application class if you use Spring Graal native project, and you have to include this annotation, Spring Boot annotation, and then proxy methods false, because GraalVM allows only JDK proxies, and the default way of Spring was CGLib. So just with this annotation, you can switch to JDK proxies, and then you have to register this PIN, which we created before, also a bit boilerplate code. So I hope that will disappear in the future. And they also provide, in similar way, the Maven plugin to build a native image directly with even more customizable things. So you can provide even arguments to GraalVM to build this. And also you can experiment with additional parameters. So also the way, but just what I see from the statistic, that Micronaut is quicker. And with Quarkus, they are similar. So this depends on the day and the release. When Spring Framework is just because they're too young, they will try to catch up. And of course, they know that how many people use Spring. So just they have a lot of cooperation with GraalVM team, but they're currently the numbers, the statistic, the last tests and so on, they're behind. So I don't want to compare these frameworks, because as I've told you, there are a lot of releases, and just it depends on your use case. But look at the parameters, what is the programming model, database, test support. They all have this, but just with limited scope. And what is really important if you do this for serverless is to look at these parameters like application size, cold start time. If you use the plain framework, it's also important. Request invocation duration, memory consumption, and if you use the native image, then the build time is important, but it generally depends on GraalVM itself, so it will be comparable probably for all solutions, but also of course native image size, cold start time, it will be hugely reduced with native image, and also the invocation duration will be reduced, and also memory consumption. So just these are things to look for. And my personal experience was GraalVM and frameworks, they're really powerful and have a lot of potential. And even if you use Micronaut and Quarkus currently without native image, it will improve your cold start significantly comparing to Spring Boot in each case, because they use as little as possible reflection. So you will have single-digit cold start in the worst case. But if you use this in conjunction with GraalVM and native image, it has its challenges, it has its heavy challenges. The first thing is that you require Linux executable. So the Windows and Mac people should use Docker for this. Also, managed custom runtime requires additional effort, just managing this runtime. And also it has performance impact comparing to plain runtime. I've mentioned this. Yeah, you should use Docker, and you will have to deal with a lot of exceptions if you do the examples for the first time. So a lot of exceptions come in from building GraalVM native image. So you have to experiment with a lot of additional build arguments. They are listed below, some links, so to find out how to solve these problems. But the first feeling is, oh, just I have written the simple function, I want to build a native image, and just I get plenty exceptions which I can't understand. It's a bit overwhelming. That was my feeling. And of course, this long duration of building of image, it just more or less complicated. So, and once again, as little dependencies as possible, just only use what you really need, and it will, yeah, that's the way to go for the serverless. So if you would like to try this yourself, there are a lot of links. Just Micronaut AWS applications with Micronaut, Quarkus, and Spring Boot, or the repository from AWS where they provide examples to use all three frameworks. So the last thing to mention is the project Leyden, which was mentioned by Mike Reinold in the end of April, which seems to have the same goal, just provide native image support for Java platform itself with the slow start time and peak performance. And it sounds similar to GraalVM, but they explain they won't merge these two projects. So they probably provide some kind of API which GraalVM will be using. But of course, there are only discussion. Nobody knows what time does it take to implement this, probably some kind of 5 years. But it will be nice if native support will be a part of Java, OpenJDK, and so on. So when we select runtime as Java, we can get this native image support out of the box, and we are not required to provide our custom runtime. So it will be a step of the simplification, but I think it's a long way to go. So this is all I wanted to mention in this talk. So thank you very much.